All right. Welcome everyone to Personalized Learning with AI, Student Data Interaction. This is the last of a series of SummOER Camp webinars hosted by eCampus Ontario Open Library. My name is Mary Gu, and I am one of the librarians with the Open Library. As we get started, I want to take a moment to share my land acknowledgement. The offices of eCampus Ontario are located in the downtown Toronto area, which are within the traditional territories of many nations, including the Mississaugas of the Credit, the Anishinaabe, the Chippewas, the Haudenosaunee, and the Wendat peoples. I myself am coming to you from these same lands as a settler covered by Treaty 13 in the Williams Treaties. And as we engage in this virtual session, I really want to thank the diverse Indigenous peoples whose footsteps have, currently do, and will continue to mark this territory. And we ask that you also consider the caretakers of the lands and waters that you're situated on. All right. There's a lot I want to cover today, so we're going to get started with a really quick intro to the Open Library, then dive right into the personalized learning aspect and contextualize that for all of us in terms of AI. Then we're going to jump into reviewing platforms. So here I'll be really looking for your engagement. Then we're going to talk about student data and advancing technologies, the thornier issues and concerns that we should all be aware of. And then wrap up with a quick beyond this workshop, at which point I'll do a quick sort of where you can find us, what else do we have going on, and then dive into the Q&A and discussion portion of the session. So the eCampus Ontario Open Library has been around since 2017, and we provide programs, resources, tools, platforms in building practices with the sector around open education. I think many who are on this session are already familiar with us, so I'm just going to move right on. And otherwise, I invite you to explore our primary homepage that just got dropped in the chat there. All right, let's start by establishing our common understanding of what personalized learning is and what the goals are. So immediately, quick chat. I'm going to launch a question to the chat. Let me launch it. A quick little poll, which says, what comes to mind when you hear the term personalized learning? Are there other adjacent concepts that come to mind? Do you have an understanding of what the goals are, for example? Who do you think it's for? What do you think are the pros or cons, perhaps? I'm going to give folks a little bit of time, 30 seconds, and then we're going to see what we get. For folks who are just joining us, we're just taking a quick poll. Hope you can see it when you get logged in to get started in the session. All right, I'm going to end the poll and see the responses that we are getting in. Just 1 second. All right, I'm going to share the results back to everyone. Oh, I think I opened the MySpace. Let's see what we got. I don't know if I'm seeing the results. I wonder if maybe Siri or Sarah, would you mind jumping on? Just let me share back a little bit what we're seeing from the poll.
Yeah, so we're getting a couple different answers. Just to read out the first few that have popped up, different pathways for different learners, learning customized to the unique needs of the learner, tailored to the student as needed learning, adaptive learning. Someone put adragogy, so if that person wants to expand on that. Skills building, tailored to what I need to learn, learning that takes into consideration individual differences in learning styles of student, using AI to help broaden your understanding of concepts, learning that focuses on students' ability/preferences, adapted to learner preferences, likes, etc.
Perfect. Those are all of the things I hope to draw out from you guys. And that's also why we're really focusing on AI and personalized learning here. So as you get a sense from, which is not a surprise given the folks here, but the really core concept of personalized learning is learning and customized instruction that considers the individual's needs or goals. And scaling the work of this type of approach to learning is one of the core challenges. So naturally, with advances in technology, this has made individual customization much more possible. And so really, when we look at personalized learning as an approach and as a way of delivering education, it has really evolved in step with technology over many years now. So when we start talking about personalized learning platform, software, technology, and its intersection with student data, let's start with a quick overview of some common data sources for such platforms. And if you have other examples, please feel free to drop in chat in terms of things that you've experienced. The first category is the learners, which we can understand as our users, probably our primary users. So the learner's behavior in terms of how they're reacting to or engaging with, say, software that's on the platform, as well as potentially how they're reacting and engaging with their devices is often captured by personalized learning systems, and that feeds information to these systems about how the learner navigates the space and the content. There's also user input as a very broad category. So this could be them responding to a chatbot, giving direct input, uploading homework assignments, or responding to interactive activities. Another common data source is the educational content that's in the platform itself. So this can be instructor or ID or created content. This can also be free online resources. Maybe that's linked or that's embedded. And of course, we wouldn't be the open library without talking a little bit about openly licensed resources. For folks who are unfamiliar, open licenses are a category of licenses that allows for reuse, adaptation, redistribution, and several other uses. The goal here is that there is a set and base understanding of things that are allowed for you to use with the content. This respects the copyright holder's IP rights, and it also can sometimes reduce the additional work that may come from attaining usage rights. And then finally, there is other systems. So other systems that might be interoperable or integrated with a personalized learning systems that allows for tracking across multiple systems. Perhaps there is interactive components that offer opportunities for fine-tuning personalized systems. And depending on what is being communicated across systems, this might even reduce instructor workload. So now that we talked a little bit about the core goal of personalized learning, talked a little bit about the data sources that are possible in terms of broad umbrellas, let's talk a little bit about what can be done with these data sources. Oh, that popped up right away. All right, so when I was digging into this content, I understood AI as an umbrella term and as a theory that existed long before these past couple of years of renewed public interest with the release of generated AI systems. But as I dove into the research for this workshop, I found there was a lot of overlap in the literature and in reporting between the terms AI, machine learning, and deep learning in particular. And for me, I want to establish some clarification both for myself, if not for folks who are joining us, so that when we talk about some of these things or refer to these things, we have a bit more clarity. And I made the chart that you see. I made a chart in order to try to differentiate between some of these terms and to categorize things a little bit, which of course naturally means that it's inherently imperfect. And we'll get into why as we look at what we see on the chart here. So first, to clarify for everyone, machine learning is an approach to AI. So it really falls under the broader umbrella of AI work. And machine learning uses data and algorithms to identify patterns in the data and make predictions based on the identified patterns from the training data. Now, machine learning methods have been used in personalized learning systems for years now, and has been a big driver in attempting to achieve that core goal of personalized learning, which is to deliver customized instruction and educational materials. But there's a lot of different types of machine learning, which is what you're seeing on the screen right now, and I'm going to talk a little bit. So in terms of the types of machine learning that are really common, I've sort of organized them a little bit based on what we are seeing in the literature. And here, the types mostly mean the type of learning, quote unquote, that is happening. And often the differentiator, in terms of at least the more classical approaches to machine learning, is the extent or the type of human intervention that happens on the algorithms. So when you're looking at the chart there from the left to right, for the first couple that you're seeing is supervised learning, unsupervised learning, and semi-supervised learning. And basically what is being described by these terms is the level of human intervention on the data set before the algorithmic processing happens. So in supervised learning, this uses labeled data sets that trains the algorithm how to classify the data in order to make predictions. And the human intervention can happen at the data set in terms of humans are labeling the data, or through adjusting the different weights of the input to tell the system what is important. There's all of these inputs, but this one's more important than the other one. This is how you should interpret it. But you can imagine how this can be really onerous when you're considering a really large data set, which is also what drives some of the LLMs that we're seeing here. To have a human do all that work becomes much more onerous. So then we have the evolution of unsupervised learning, which uses raw data sets that are fed into algorithms, and the algorithms detect patterns in the data sets without any human intervention on the data or the processing. One of the pros of this is that algorithms can sometimes detect deeper patterns than is immediately or readily obvious to a human being. And then we have semi-supervised learning, which is sort of the middle option, as the term suggests. So for example, what that looks like is that for example, somebody who is developing a machine learning platform may provide a smaller data set that has been labeled. So there is a human intervention happening here as a part of training the algorithm. And then the algorithm takes the interpretation and the processing of that initial labeled data set to then process a larger unlabeled data set. So you get a bit of the pros of both previous types of machine learning. And now we get into reinforcement learning in neural networks. So this is where we start getting to types that are not really based on exactly the extent of human intervention, which is why I call this categorization a little bit flawed. But I think it's important to mention because these types of machine learning is very common in personalized learning systems. So reinforcement learning is really based on the work of behaviorism, and it does require human intervention. But instead of training on a data set, the model is learning through a trial and error process, and correct responses are typically rewarded to let the system get closer and closer to making as many correct outputs as possible. And then we have this category called neural networks. And this is a type of model, type of organizing the algorithm processing that's really inspired by the biological sciences work on neural connections, so your brain connections. And then in this kind of model, the input moves through sometimes multiple layers of interconnected neurons, and pulling again from that terminology and from the biological sciences. The neurons themselves are connected to other neurons sometimes with weighted connection. Again, a way to tell what is important, what is not. But this model is really more of a way of processing the input as opposed to a descriptor or an indicator of the level of human intervention. And it can be used under the various approaches that we mentioned already. The advances that we've seen in generative AI really comes from this work in neural networks. And neural networks can be used, as I mentioned, with multiple other types. So for example, in a supervised learning approach, we can consider that the neural network is how the algorithm will process the input, but for example, it processes input that is labeled. So the data set is labeled as part of the training. So this is sort of what I mean by these categories are not really perfect, but I think it's really important for us to chat about because then I think it's important to think about some of the implications it has for student data that we're going to go through. The main thing for me that I picked out when I looked at some of the example methods that I've listed there is that the example methods can be used under different types of machine learning approaches. In complex systems, such as personalized learning platforms, probably uses more than one. And that can be really important when we're trying to make decisions related to student data. All right, so we got a little granular. So let's talk a little bit more about what these example methods can be done. Are we done? How these example methods can be actually implemented. There's an excellent review that I cited there that went through many different examples, and I pulled a couple here. So for example, an algorithm can be used to analyze learners' requirements that have been gathered through a chatbot interface in order to generate out tailored educational content. Or we can use algorithms to cluster learners, allowing instructors to then design specific learning strategies based on those cluster characteristics. We can also evaluate learner performances in order to classify the learners into groups based on their behavior, so that user input, and then perhaps offer at-risk groups a self-tutoring program to help them through the rest of the content. And given the power and the fluidity that we're seeing from the large language model, natural language processing, and deep learning methods, it's easy to imagine what more can become possible with these technologies as it continues to advance. Which brings us to the type of personalized learning tool that we'll use as an example to think through the possibilities, issues, and approaches in student data. So I want to talk about chatbots in tutoring systems. When I was taking a look at these systems, I definitely saw a lot of overlap, which is why I kind of presented them together here. The main thing that I pull out is that it's sort of the primary intended user and the primary goal. So tutoring systems, typically it's aiming to help the learner understand educational content and achieve their learning goals. And then with teaching assistant platforms, often very similar, often like structurally, the main goal here though is to help an educator prepare and deliver content is sort of what I've noticed. And if you're looking at the platforms that are the example platforms listed on the screen, you'll notice that there's a couple overlaps. And that's one of the things that I noticed when looking at these. Other thing I noticed when I was looking into existing platforms was the amount that was targeted towards children, which I was surprised by. And so we can think of lots of scenarios, I think, even without the ones that's on the screen about why this might be advantageous. A specific one I want to mention is for massively online courses that may be trying to deliver educational materials to a really wide audience with very wide contexts. And especially if such an instructor is also using openly licensed materials, this might be a really easy way to start being able to, for example, provide lots of example tests or provide lots of different formats of the educational content to support different types of learning. All right, I went through a lot of content, and now we're going to take a moment and I'm going to get your interaction. So it's time to look at 2 example platforms and that have open public interfaces, and we'll start drawing together some of what we talked about and start thinking about the student data and platforms aspects. So for this exercise, we're going to look at Contact North's AI Tutor Pro, as well as Lumination's TutorAI, which is privately owned. So the links are in the getting dropped in the chat. So as a note, Contact North does have a English interface as well as a French interface. I ask that you open one of these platforms, unless you're like a web browser warrior and can do 2. And the next slide, I'm going to have some instructions for how we're going to explore this. I would really appreciate if folks share back some of your findings through the chat. So let's look at these platforms and consider what we can learn about how these platforms engage with, understand, and interact with student data. All right, so here's my instruction slide. So this is the example platform with the links. As a reminder, here's the broad categories of data sources we talked about. And now here's the questions I would love for us to walk through. So folks who have your browsers open, please take a look at these platforms, browse around, look at what's available in terms of the website presence for one of these platforms. And my first question is, who is the intended audience for this platform? Set myself a little timer and give us a little bit of time for each question. Oh, thanks, Siri. Appreciate you dropping that in. Don't feel like you have to answer every single question at once. If you have the answer to even just one of them, drop it in. And do let us know which platform you're looking at if you're providing answers. Hey, folks, I think I saw a couple of people just joining. We are currently at the platform review part of this workshop. We have some links that were just dropped, and also the slide gives you all the instructions. But I'm asking folks to do is to take a look at one of these platforms, think about the data sources that are possible, and also to answer some of the questions that you're seeing in the slide. So the first question is, who is the intended end user for this platform? So I'm seeing that somebody took a look at Contact North, and that's in terms of who is the intended audience. Is that anyone at Contact North, perhaps, or anyone for Contact North? So it could be anyone. Yes. We have learners to elementary to professional. I think that one's very interesting. I wonder if maybe they could clarify if that was for AI, for the Tutor AI or for AI to Tutor Pro. And I see that somebody's jumped over, found that for Contact North AI Tutor Pro, there is a privacy policy that's available. Perfect. So the learners for elementary to professional is the AI Tutor Pro audience users. And then I see that somebody's pulled out that Tutor AI really seems to be learners of all kinds, and I'm getting some thumbs up. People are getting to the same conclusion. Can you figure out what is the technology behind each of these platforms? Is it an LLM even? Is it some other kind of machine learning like we talked about? And if you do find out, I would love to know where you found it. And for folks who have found or are looking at privacy policies, love to know if you can determine what data is collected and how that data is used. All right, yes, AI Tutor Pro is using ChatGPT. I found that they were quite clear about that, which I thought was great. Yes, that's right. They have specifically named which version of ChatGPT they're using as well. I'm gonna give this another minute and a half. Has anybody found out what data is collected for each of these platforms yet? Okay, there's a few. So somebody's pulled out the specific privacy policy for Tutor AI. I agree. They do actually list that quite decently clearly, I think, for AI Tutor Pro. Yes, that's right. We do have a set of contact information pulled out, and they do list it quite granularly, actually, which I think is quite interesting. And yes, that's right. Contact North is using Google Tag Manager as well as other Google Analytics. I personally appreciate how they pulled that out specifically. All right, we're going to last 30 seconds. We're going to see what else comes up. Okay, I'm gonna just put a pause now. If anybody does have things that they did find out and they do want to share in the chat, please do. I'm gonna share a couple observations that I noticed. Yes, Jen, that's right. Tutor AI does know they keep the data indefinitely. So in terms of observations I made when I was digging into Tutor AI, I gave myself a shorter period as well, so that we're kind of all in the same round. And some of these questions, I think it's interesting is that I think it only really becomes obvious as you have to do more digging. And actually, these questions are questions that I think is good for any one of us to consider when we're engaging with any kind of technology. But for Tutor AI, one of the things I found that was interesting was that certain aspects of the questions I'm asking was only obvious in the terms of service and not in their privacy policy. So, for example, they do clarify which is their legal jurisdiction. They also mention what happens under a service interruption, which they say which they have a statement related to personal data, which I thought was interesting. Um, And then for the privacy policy, a couple things that I pulled out, folks already mentioned already, was the variety of data sources being collected. They have a data transfer disclaimer in terms of how data gets moved to various servers or various services, which I thought was quite interesting. And I think you can really see that this is made with some aspects of the GDPR in mind. And we're going to talk a little bit about that too. For Contact North, a couple of things I thought was really quite interesting, given sort of the audience, is that they have a privacy and use by minors policy. And they note where their servers are located, as well as the specific fact that user data, retraining based on user data is not allowed. And finally, there is an acknowledgement from Contact North's platform related to uploaded copyright data being treated as interaction data, which then has implications for if you're using copyrighted or open license or your personal information. Yes, that's right, Corinne. They do have the UFT has done a privacy impact assessment, I believe it was, which is available online if you're looking for it. I don't have the link though. So And also, the one last thing I did want to know about Contact North that I thought was very interesting is that they on the platform, once you start using it, beyond the first immediate landing page, is that they have disclaimers related to accuracy and whether or not the user should input personal information, which is to say they shouldn't. But I thought that was really neat. All right, so we started with talking about the possibilities of using AI in personalized learning. And now that we look at some platforms together to engage your curiosity and some really great responses about what you found. Let's start thinking about the thornier issues related to student data and using advanced technology. So as we dig into this, often when we're talking about data, we're actually talking about privacy and security. And when we talk about privacy, we're also often talking about really the violations or breaches of privacy, which is how it's linked and overlapped with security issues. Given that many of us, I'm sure, have seen news of data breaches and also perhaps have even been impacted by those, even if it's just an old account that got leaked and now you're getting a lot of spam emails. This is really important for us to think about, given the sensitivity of student data, especially with the potentials of a personalized learning system that collects user input. So I'm not really going to get into any sort of concept differentiation between privacy and security because we're going to use these concepts together a little bit. The one thing I did want to acknowledge is that often when we talk about privacy, it's through the lens of an individual's rights, whereas security can be understood through individual or organizational lenses. And this can be really relevant when we start looking at the legislative landscape. So on the privacy side, the major pieces of legislature that I'm sure you're all familiar with is first and foremost the Canadian PIPEDA Act. But there are other pieces of legislature that has a pretty big impact on the technology sector, which is the California Consumer Privacy Act and of course GDPR from the European Union. On the AI side, just this summer, the EU has released their Artificial Intelligence Act, which will, I think, be a baseline framework and maybe a reference point for many other jurisdictions. But also worth noting is that the US has released some copyright guidelines related to AI acts AI generated content. And finally, in Canada, worth noting is that it's been proposed for a couple of years now is the Artificial Intelligence Data Act. And as an aside, sort of as the intersection of privacy and AI, I think it's worth noting or being aware that the Office of the Privacy Commissioner of Canada has launched an investigation into OpenAI. They say it's in response to a complaint alleging the collection, use, and disclosure of personal information without consent. So we're kind of in this tricky, murky area, which happens when technology outstrips our social norms, our regulations, and our protections. So let's dive in a little bit more with the legislative aspects. So in terms of PIPEDA, I'm not going to go through all 10 principles or really any of the principles in great depth. I think our audience is quite familiar actually, but a couple of things I want to pull out and given the exercise we just did is the principles related to identifying purpose. So again, getting consent, about applying appropriate safeguards to any personal data collected, and as well in terms of the individual's rights to challenge compliance by an organization. And we're going to look back on some of these concepts again when we get into the specifics of issues with generative AI. And with the EU Act, a couple things that I thought was really interesting when you look at the Act itself is that it's definitely a very risk-based approach, and the obligations fall primarily on the deployers and providers of AI systems. And one thing, a particular note is that in the the EU AI Act, the first couple of chapters are split by categories of AI systems, and it goes from prohibitive to high risk AI to general purpose AI. And there's sort of regulations and responsibilities that are set out in that framework there. And in terms of privacy and data rights, the EU Act does note that privacy and data rights are governed by existing regulations, directives, and that's maintained. That providers and deployers of AI systems are understood as data controllers and processors and continue to have those responsibilities under laws protecting personal data. In terms of the Canadian Act, so also a risk-based approach where obligation are the developers and deployers of AI systems increase relative to the risk presented by the systems that's being developed. And PIPEDA is still understood as the basis for any guardrails related to personal information used by businesses creating AIs. Although in this act, there's also a proposed Consumer Privacy Protection Act that may evolve via PIPEDA. So it'll be interesting to see. Conceptually, for me, certainly it rings a bell that's very similar to the EU Act. And in the recent federal budget that came out that had included a lot of measures for AI, it did specifically mention the development of the Canadian AI Safety Institute, as well as work to strengthen the Canadian ADA Act, which is Artificial Intelligence and Data Act. So there's lots that we'll see evolve over this next year, I think. So let's talk through some broad privacy concerns now that we know why we care, what is being collected, and sort of the legislative landscape. And we're going to talk about some of these concerns as it relates to generative AI, which are also sometimes known as foundational models. Because the build of these models has some implications for the data and the kind of security concerns that may occur. The first one is probably one that most people are pretty familiar with, which is the consent and autonomy in the training data. It's also the site of several pieces of litigation right now. So what happens with that really remains to be seen. The major aspects here are whose data went into the training model and consent on the data or data be rescinded. And what does that practically mean? Given that in the privacy legislations that exist, consent and opportunities to challenge compliance are really important aspects. Next, we have retraining models. So a hallmark of generative AI models, these big foundational models, is that they're trained on huge data sets, which allows them to perform with so much flexibility. But having enough training data is already a general challenge for developing these models. And one proposal, of course, is to take human user data post-initial training to retrain models in the future to make them better, more responsive, more accurate, to have also more natural data for the predicted models to fit to. But of course, from a personalized learning approach, retraining using a learner's actual data is probably the ideal. That's what we're trying to get to. We want to be responsive to the individual, to the human user. But this immediately intersects with the issues around learner consent and the possibility and feasibility of data removal, which is a tenet in existing privacy laws. And removing data from these large foundational models is a challenge that a lot of researchers are grappling with, and they have been for a while. We'll touch on that in a bit. Next, I want to talk a little bit about biometric data, which is a category of data that includes images with humans, speech, posture, how you move in the world. And this offers a lot of opportunities in terms of ed tech, such as making content or a learning experience more accessible, allowing a learner or an educator to adapt content. So for example, if you were trying to generate a instructional video and you wanted a human AI agent to do that speaking, that's probably using a model that's trained on biometric data in order to create that AI human image, rather, I would say. There's also opportunities there to provide multimodal education. So there's a lot of pros that can come. But using such data for training is inherently more risky from a security point of view, as it could be used in identification or surveillance, and a data breach could have greater impacts. And this is all the more so when you combine that with issues related to retraining models based on user input. All right, the last three categories I really want to talk about. So this concept that you're seeing here are around horizontal relationality. So this is a concept and a capability that is a built-in feature of machine learning. So you may remember machine learning aims to use data and algorithms to then make predictions or outputs that are very similar to the data that went in. And the concept here is best demonstrated by using an example of biometric data. So say a human model consents for their images, videos of themselves moving to be used in a training data set. They licensed their image, perhaps they gave consent, they were paid appropriately. But then what that ends up meaning is that someone who is blood related to that model, or perhaps just simply shares similar features, is more likely to be identifiable simply because they're more similar to the data training, which is essentially what horizontal relationality is, like with like. But you can see how that's a feature given the nature of statistical models and the purpose of generative AI. But horizontal relationality then has implications due to the potential of a data breach. Or what if, and basically what that means is that an unconsenting individual is potentially impacted by what another consenting individual chose. A sort of a metaphorical example might be the 23andMe leak related to folks with who shared their genetic data consensually, but that had impacts for folks beyond them. A next category of privacy concern is the use of human-centric computer vision, which is already used in a lot of technologies that you and I are probably already using, such as your apps on your phones that do automatic photo tagging or your Face ID sign-in. These are incredible technologies for developing accessible supports and just reducing friction in our daily lives. Excuse me. But this technology is inherently responding to human identifying data. And of course, I don't think I need to say too much about surveillance-based edtech and the potential harms and algorithmic bias that can occur. So finally, the last example category, and this is why I'm talking about privacy and security hand in hand, is the general risk of cybersecurity. So right now, a lot of these large training data sets that go into the LLMs, for example, and the generative AI models are generally not encrypted. And many of these models are pulling from the public web. So copyright, IP, and consent issues aside, that might not present the same level of cybersecurity risk since there's already content that's available. But combine that with the issues that we mentioned above, plus some of the goals of EdTech, especially personalized learning, wherein user input to provide a more personalized experience, that now means that potentially identifying sensitive student data that may not be encrypted when it's used for training, but that training is part of what makes the system so responsive, so flexible, and therefore so fit for the purpose. Now, I mentioned that some of these risks compound. I hope you got a sense of that as we talk through these things. Another useful way to conceptualize the full impact of these concerns is to consider how these concerns may interact throughout the data lifecycle of building a generative AI model. The 2024 article by some folks with Australia's scientific research agency, the Commonwealth Scientific and Industrial Research Organization, they created this figure that maps specifically privacy and copyright challenges throughout a data lifecycle of building a generative AI model. So again, the references are all available with slides. I thought this was a great article. Now to talk a little bit about what you're seeing on the screen. Along the horizontal x-axis is the life cycle of a data for building an AI model. It starts from problem formulation, data collection, data cleaning, data annotation, model training, model evaluation, model deployment and inference, and to data distribution, so downstream. And then along the vertical y-axis are the broad categories of privacy and copyright challenges that can exist with generative AI. I do recommend reading this article because I feel like it really talks through these considerations really clearly. And when we look at this chart, there's three things I want to pull out for us right now. The first is that many types of challenges affect multiple parts of a data lifecycle. Second is that data cleaning is really the only part of the life cycle that doesn't seem to be at risk for privacy or copyright challenge, which kind of makes sense. That's probably where the researchers or developers are applying their data removal policies. And often the last thing that I noted was that often challenges that arise in an earlier part of a data lifecycle also impacts challenges that arise at a different part of the data lifecycle. So an excellent example is the provenance and attribution aspect. So even if data that goes into training is labeled accurately, although that is in itself hard, what if consent is removed later on? Or what if, because of the way that the statistical model is working, it is not outputting the provenance information accurately, consistently, or perhaps even at all? All right, that's a lot of issues. That's a lot of concerns. And surely someone somewhere out there is doing something about it. And yes, there are. Researchers, philosophers, technical folks have been grappling with these problems basically as long as they've been working on machine learning and artificial AI. And in terms of what you're seeing on the screen, these are some of the technical approaches that are currently being tested, sometimes applied, to address some of these problems. So at the site of the AI model, there's a lot of work being done around privacy preserving deep learning. So deep learning, as you may recall from earlier, is a type of neural network approaches to machine learning. So how do we develop privacy preserving versions of this? So there's a couple methods that exist in the literature. So first is differential privacy, which is a way to mathematically add noise to the aggregated result of the computation. So this is after raw data went through computation by the algorithm, and then you add noise. I've been sort of thinking of it as like my Zoom blur filter. So you're seeing the result of what my computer is displaying, but the blur is applied afterwards. Next is federated learning, which is distributed networks with a single global model that doesn't access the raw data from the distributed sources themselves. So that, for example, could be all of our smartphones. Your raw data, your interaction with, say, an AI that's on that model is kept locally, but then the aggregate results, the patterns that are being seen can be fed into a global model. And the global model can update down to our phones, but it doesn't access any of your user logs, for example. Next, there's homomorphic encryption, which is a way to allow raw data to be encrypted and still be used in data sets, which is about as far as I understood that work. Finally, there's also work on machine unlearning. So the opposite of machine learning, which is essentially how do you remove the influences of the training data from a trained model? So and this can be really influenced by the specific types of data and the algorithm or the machine learning task that's happening. And this kind of work has been really driven by the GDPR's right to be forgotten. The techniques here also really aims to balance the need to be accurate in the unlearning with the cost computationally and accuracy-wise of the unlearning. The currently most commonly used type of machine learning is called machine silencing. So if you ever work with ChatGPT or perhaps your institution is engaging with trying to build your own version, you've probably been able to ask for, hey, I don't want it to answer these questions, or I don't want it to I wanted to block access about certain types of information. So that's machine silencing in work. Then there's also data poisoning, which is to contaminate the training data set itself, introducing more statistical noise, which leads us to sort of broader practices that can be done. Since data poisoning, I'm not really sure that there's many model creators that are doing that unless it's for testing, but it certainly has been done by general creators in the public web who are sharing their work online as a way to reduce the ability of existing generative AI to process their creative works. And in terms of broader practices, this is really more about our evolving user behaviors in response to the availability of these technologies. A couple of things that I found really interesting. First was consent tagging, which is like technical ways of adding in tags on any content that's shared on the web. Since getting consent for grabbing content to go into data training sets is really difficult and it's very onerous. This is a way that as somebody uploads their content to the web, shares it out, that tagging is already in there. And also, very interestingly, there's the social link data for federated social web applications. So basically, similar to some of the things we talked about, wherein we separate out the global model from your user data. This is a version where your user data is stored on your device, but there's protocols and applications available that can communicate with with multiple or different social web applications. So you can still engage in an online social community. Now, I want to take a moment to talk a little bit about the Creative Commons and AI data sets. So open licensing again. CC licensed materials can be adapted from. It's part of the conditions of certain licenses. So please note, not all CC licenses allow adaptation, but some do. And using such licensed content in general systems can be understood as adaptation. So for example, when we looked at Contact North's platform, we did see that we can upload content and have it generate out tutoring materials for us. But the expectation still, the current expectation for how we navigate the space is that the attribution feature of the Creative Commons license is still preserved. So if Creative Commons materials goes into a generative AI system, you are still expected to make attributions with the output. And that is easier in some situations than others. So the example that we saw with the Turing platform, when a user uploads a specific item and it gives you an output, that is a bit easier to give an attribution because the input output was more direct and also more linked. But even if we don't get into the statistical aspect of what it's generating out. But that's much harder if you're considering when you're building training data sets or when you're drawing from the public web. However, perhaps with the evolution of consent tagging, that can be an evolution of the licenses themselves. So there's lots of interesting possibilities that are ahead of us, I think. I'm going to leave that there as this isn't really the focus of this topic, but I thought I want to ground it into an open topic near and dear to the library. Okay, that was a lot of content. So what's next? And I actually want to turn this question back to you, everybody here. I'm going to launch another poll right now. Now, given the issues that we talked about, all of the granular detail, when you consider the platform review exercise we did earlier, what questions might you want to ask when you're evaluating an AI tutoring platform? I'm going to give folks a minute to respond. All right, I'm at a minute, so I'm going to end the poll. If I can ask Siri, if you could share with me some of the results that we're seeing.
Yeah, so some of the answers, so accuracy, privacy, integration with current ed tech platforms, how much time will it take for me to figure out its appropriateness and implement it? If there's a visual aspect available, most platforms this person has seen are all text, and a question of, is it really safe for younger students? Someone else asking, is the privacy statement clear and truthful? Is it actually knowledgeable on my topic? They don't want their students learning something from AI that isn't correct or doesn't align with how they teach the concept. Someone else interested in accuracy and how to incorporate it properly for teaching. And then another one, how accurate is the output? Where is the data sourced? Is it attributed? Another couple questions about customization, level of output, how and where data is stored. And then another one, who is responsible for output quality?
Output quality, that's interesting. Thanks so much for sharing those back. Those are all really important questions. So I like to wrap up on three really broad questions. We went a little granular at various points of this workshop, but we're going to pull back a little bit. So I think the really three key questions that I want to leave all of us on are first, what are the platform's data policies writ large? What is privacy policy? Does it have policies on personal information? Does it say anything about data collection, transfer, storage, and use? What are the platform's terms and conditions used? So when the person who share, how do I engage with this? How do I assess this properly? Do you understand the terms and conditions of use? Do you feel like you have transparency on this? And finally, the question I think it's worth always asking is, what alternatives exist? I think it's an important thing about these issues, and I'm sure that's part of why you're here, when engaging with emerging technology as a way to understand our individual rights to our data, privacy, security, but also when we're participating in each of our respective organizational responsibilities. So for our educators who are also decision makers, I think the last question is really extra important. Because when tech is selected for education and applied at an institutional level, can a student truly consent if there is no alternative presented to them? I think there's probably many students for whom a personalized learning experience is definitely worth any potential risk. But it's obviously incumbent upon all of us to present the risks and possibilities really clearly and to be prepared with alternatives. The questions that we ask as part of the platform review, I think, are applicable across different technologies, as well as sort of these three really broad questions that we can all engage with as part of being citizens in the world. So that's the main chunk of the content today. I'm going to talk to you a little bit about what's new with Open Library, and then we're going to stop recording and we'll have a chance for a discussion and Q&A. So folks, please stay on if you want to chat more. So you can find the Open Library at these various links that we're going to drop in the chat. Primarily, if you want to stay tuned to our other events, please check back. We're taking a tiny minor break from doing events for a little bit as we have lots going on, including really exciting to share, which is the Mastering Open Ed micro-credential that we're launching for the first time. We still have room in our French facilitated cohort if anybody's interested. I do remember seeing here from some folks who might be francophones. And we would love to have you here if you want to get a grounding and learn some foundational skills around open education. I also want to share a little bit about eCampus Ontario's other platform services that might be particularly relevant to our audience here today. First, there's EdTech Sandbox, which is where you can find educational technology. One of the cool things about the platform is that you can filter and search for technologies who have partnered with us to make pilots available, so you can get a license and try it out for free for a term. There's our micro-credentials portal where you can search for all of the micro-credentials offered by Ontario publicly supported post-secondary institutions. We have the Learn Online portal, which is your opportunity for yourself or anybody to search all of the online distance learning opportunities that exist in Ontario. We have CapFlow, which is for our francophones community to engage with a platform and explore and engage with work integrated learning. We also have OSIP, which is our platform that connects businesses with a thorny research question with researchers in Ontario's post-secondary landscape who can help them solve that problem. All right, I am going to stop recording as soon as I get there. And while I figure that out, I'm also going to launch our feedback poll. If you wouldn't mind taking a moment to answer that, I am going to start recording.